Welcome dear students. I hope all are fine and safe by the grace of God. Shall we continue with the maths class now? Yes, please come. Okay. In today's topic, we are going to learn very simple things what we have already learned in our 10th standard syllabus only. Just an elaboration, few extension of the concepts alone. Okay. In 10th standard, you might have learned quadratic equations. Is it clear? Yes. Now, we are going to learn quadratic functions. Quadratic functions. Now, let's see what is meant by quadratic functions. A function of the form p of x is equal to ax squared plus bx plus c, where a comma b comma c belongs to R are constants and a not equal to 0 is called a quadratic function. First, we know what is meant by a quadratic equation, isn't it? Yes, the highest power in an expression of x which has 2 is said to be a quadratic expression. Yes or no? Okay. Now this quadratic expression can be expressed as quadratic function. In which form? That is p of x is equal to ax squared plus bx plus c. If any equation of this type is said to be quadratic function. Okay. Now already we know what is a, b and c. They are constants. Very specifically, this a, b, c belongs to R. What does this R represent for? R stands for the real numbers. So already in our introduction class we discussed elaborately what are real numbers, what set of numbers are clubbed into and called as real numbers. Okay. Now constants, and a is not equal to 0. Why this specific eligibility for this expression? Because if a takes the value 0, if a is going to be equal to 0, then we won't have this x squared expression. Yes or no? 0 into x squared will become 0. So this p of x will be equal to bx plus c alone. This bx plus c will not be termed as a quadratic. Yes or no? Okay. So that's why very specifically we take a not equal to 0. Okay. Now this is called a quadratic function. Is it clear? Okay. Now this is also what you have learned in your earlier classes. If p of t is equal to 0, where t belongs to real number, then we can demand that t is 0 of p of x. Yes or no? Okay. Now what is meant by p of t? Instead of x, we are going to substitute t in the quadratic function. Okay. Where we have in the place of x, we are going to substitute what? X is equal to t. If the whole value reduces to p of t is equal to 0, if the value, the final value of the expression leads to answer 0, then I can demand this t is a what? 0 of p of x. T is a 0 of p of x. Is it clear for you? Okay. Now little more elaborations we are going to learn. What are the ways to solve the quadratic functions, or what is the formula we are going to learn, and what is the nature of the quadratic function. Shall we? Okay students. Now let's discuss these things in this exercise now. Okay. The first one. To form a quadratic equation, ax squared plus bx plus c is equal to 0. Already I told you the quadratic equation is of this type. Ax squared plus bx plus c is equal to 0. Now, in order to form such a quadratic equation, there is a format you already know, and we have learned in our earlier classes also. That is nothing but x squared minus sum of roots into x plus product of roots is equal to 0. In order to form a quadratic equation, if the roots are given. Okay. So this is the format. This is the format to form a quadratic equation. In order to frame this equation, I need the value of sum of roots and product of the roots. Okay. We know that already. For a quadratic equation, we will have two roots. Okay. Yes, according to the highest power of the x given, we will have the number of roots. Okay. Now, again there is one more format in order to find the sum of roots and product of roots. Now, look into this. Sum of roots is equal to minus b divided by a. Minus b divided by a. What is b here? It is the coefficient of x. B stands for the coefficient of x and a stands for the coefficient of x square. Okay. Now product of roots. What is product of roots? Product of roots is equal to c divided by a. Now c stands as the constant and again a stands the coefficient of x square. So these things, both the things you have to memorize it. Okay, thoroughly. Okay. Now one more thing we are going to discuss under this exercise is solving the quadratic equation. We know that there are different forms of solving quadratic equation. So the first one is simple factorization. Simple factorization. The second one is quadratic, using quadratic formula, and the third one is square completion method. Do you remember all these three things? Now what is meant by simple factorization? Simple factorization, we will split the numbers. If it is going to be 24 and we will split the numbers into 2, the addition of the other two numbers. So this we will deal with the sums which are based on the exercise 2. So this type of method of factorization is said to be what? Simple factorization. Now coming to the quadratic formula, do you remember the quadratic formula? It is minus b plus or minus square root of b squared minus 4ac divided by 2a. Do you remember this formula, quadratic formula? Okay. The next one is square completion method. It has few steps of procedure to be followed for this square completion method, and this too we will discuss elaborately in our exercise problem. Shall we? Okay students, let's discuss the second sum now. The first sum is going to be a homework for you and it's very simple sum. Two roots are given. You are going to form a quadratic equation by finding sum of the roots and product of the roots. You send me, let me check your understanding of that first sum. Is it clear? Okay. Now discuss the second sum. A quadratic polynomial has one of its 0, 1 plus root 5 and it satisfies p of 1 is equal to 2. Find the quadratic polynomial. Okay. Now in order to find the quadratic polynomial, the two clues are given. The first one is 1 of its 0 is given to be 1 plus root 5 and also it satisfies p of 1 is equal to 2. What does this p of 1? This 1 value will be assigned to x in the polynomial expression. You know this, isn't it? Yes. So p of 1 will give the remainder after substituting, it is equal to 2. Okay. Let's see how we are going to proceed this problem. Okay. So first, in order to find the quadratic polynomial, let us guess, let p of x is equal to, we can assign the polynomial expression in terms of the unknown values as x square plus px plus q. This p and q are your choice. Is it clear? Okay. Now since it is given to be a quadratic polynomial, the expression should start with x square. Okay, don't give any constants here. You just start with x square plus px plus q. This is going to be our starter. So you have to have it in mind how to start with this solution. Okay, now in this, one of its root is 1 plus root 5. So one of its root, that is the value of x, one of the value of x is 1 plus root 5. So what I am going to do, since one of the root is 1 plus root 5. Okay, what I am going to do, I am going to substitute x is equal to 1 plus root 5 in first equation. In the first equation. Shall we? Now, what do I get? P of 1 plus root 5 equal to x squared. Now, x takes the value 1 plus root 5, isn't it? So, substitute wherever is necessary. So, 1 plus root 5 the whole square plus p into 1 plus root 5 plus q. Let's take this as the second equation. Okay. Now, one more information is given. What is the other information given? P of 1 is equal to 2. P of 1 is equal to 2. Again, I am going to substitute x is equal to 1 in which equation? first equation. I am going to substitute this. X value is 1. Okay. When I substitute, what I will get? P of 1 will be equal to, now x squared 1 plus P plus Q. Yes or no? Equal to what? 2. Now, this 1, if it goes to that side, then this equation P plus Q will be equal to 2 minus 1. So, P plus Q will be equal to 1. Let us take this as third equation. Okay, shall we continue? Okay, students, let's continue. We know that the second equation is given to be 1 plus root 5 the whole square plus P into 1 plus root 5 plus Q is equal to 0. Already we know that. Okay, now look into this. Wherever you see the expression of this type, one term plus the other term, the whole square. Maybe it may be an addition symbol or subtraction. When you see like this, you have to go for the expansion of a plus b the whole square. Okay, now let's expand this according to the identity. So now a plus b the whole square, a squared plus b squared plus 2 into a into b. So what will be the answer? 1 square. 1 squared is 1 plus root 5 the whole squared is 5 plus 2 into root 5 plus p into 1 plus root 5 plus q is equal to 0. Okay. Now 1 plus 5 is 6 plus 2 root 5. I cannot add this together because 2 root 5 is a third number. So I cannot add this 2 root 5 to along with 1 plus 5. This is separate term. So 6 plus 2 root 5 plus p into 1 plus root 5 plus q is equal to 0. Now only just keeping the p and q term alone on the LHS, I am going to place this on the RHS. So I will get p into 1 plus root 5 plus q is equal to minus 6 minus 2 root 5. Okay. Now let us take this equation as fourth equation. Okay. Already we have the third equation to be p plus q is equal to what? 1. So this is going to be our third. Already we have discussed this. Okay. Now we are going to solve and find the value of p and q in order to form the quadratic polynomial. Okay. Now we are going to use the elimination method to solve this. Shall we? Okay. Now look into this. Here also I have q and here also I have q. Shall we eliminate by just interchanging the signs alone? So this becomes minus, minus and minus. So this plus q and minus q is getting cancelled. From here I have p 1 plus root 5 minus p is equal to, now minus 6 minus 2 root 5 minus 1. Minus 1. Okay. So now what will be the value? Okay. Now look into this. P into 1 plus root 5 minus p equal to minus 6 minus 2 root 5 minus 1. Okay. Now I am going to club this. Since p is common in both the terms, I am going to club it. So p into 1 plus root 5 minus 1 equal to, now minus 6 minus 1 is minus 7 minus 2 root 5. Okay. Now look into this, plus 1 and minus 1 is getting cancelled. So I will get p into root 5. It is p into root 5 equal to minus 7 minus 2 root 5. Okay. Now I want the value of p alone. So p is equal to minus 7 minus 2 root 5 divided by root 5. Okay, you can leave the answer as it is, or since we never stop with this expression, because if the denominator holds with a third, root 5, root 3, root 2, what we will do in order to simplify, we will multiply and divide by the same third. Okay, so the same thing we are going to repeat it here also. Now minus 7 minus 2 root 5 divided by root 5. I am going to multiply and divide by root 5. Root 5 into root 5. Yes or no? Now look into this. Root 5 into root 5 will become just 5 alone. So p is equal to, division in division we will have only 5. Root 5 into root 5 will give you 5. Now you multiply this, minus 7 into root 5 will become minus 7 root 5. Okay, minus 2 into root 5 will be minus 2 into 5, isn't it? So minus 10. Yes or no? So now this becomes the value of what? P. Now we have come to the conclusion of finding the value P. With the help of this value, we are going to find the value of Q. Shall we? Okay students, so we arrived to the value of P minus 7 root 5 minus 10 divided by 5. Now, in order to find the value of Q, we are going to substitute the value of P into the simplest equation. We have two equations, isn't it? Second and third equation. So, we are going to substitute the value of P in this simplest equation, P plus Q equal to 1. Okay. When we substitute, what you will get? Look into this, minus 7 root 5 minus 10 divided by 5 plus Q is equal to 1. Now I am going to take this constant to that side, isn't it? Okay, now look into this, we have minus in common. So shall we change this as minus 7 root 5 plus 10 divided by what? 5 plus Q is equal to 1, isn't it? Now take this to that side. So Q will be equal to 1. If this minus goes to that side, it becomes 1 plus 7 root 5 plus 10 whole divided by what? 5. Okay. Now we are going to make simple modifications over here in order to find the value of what? Q. Okay. Now look into this. Now since it is in the fraction 1 plus, it is a fraction, isn't it? So what we are going to do? We are going to take LCM. So Q will be equal to 5 whole divided by 5 plus 7 root 5 plus 10. So now look into this, very simple. So 5 plus 10 is equal to 15 plus 7 root 5 whole divided by 5. So now this becomes the value of Q. Now we found the value of P as well as we found the value of Q. Now the required quadratic polynomial is given by. Now we are going to substitute the value of P and Q in the first equation. So this becomes x squared plus, what is the value of P now? Minus 7 root 5 minus 10 divided by 5 into x, now plus 15 plus 7 root 5 divided by 5 is equal to 0 is the required answer. Okay students, let's discuss a very simple sum now. Okay, now if alpha and beta are the roots of x squared plus root x plus 3 equal to 0, form a quadratic polynomial with zeros 1 by alpha comma 1 by beta. Okay, now we are going to form a quadratic equation with the roots 1 by alpha comma 1 by beta. Now what does this mean? This is a quadratic equation with the roots alpha and beta. Okay, already one root and two roots are given for the quadratic equation. With this sample, we are going to form one more new quadratic equation with the zeros 1 by alpha comma 1 by beta. Okay, shall we see how we are going to proceed? Now first, given alpha comma beta are the roots of what are the roots of? X squared plus 2 root x plus 3 is equal to 0. Yes or no? So now as it is given to be the roots, now what will be the sum of the roots? Sum of roots, that is alpha plus beta, will be equal to, now in order to find the value, first as soon as you write here, you write and keep, what are the values of A now? A is equal to, x squared coefficient is the value of A, isn't it? So A is equal to 1, B is equal to root 2 and C is equal to 3. Yes or no? Okay. Now, what are the sum of the roots now? Alpha plus beta equal to minus b by a equal to minus 2 root 2 divided by 1. The answer is minus root 2. Yes, is it clear? So, we found the value of alpha and beta, the sum of the roots. Again, I will write it here. So, alpha plus beta is equal to minus root 2. Box it and keep. Okay. Now, what will be the product of the roots now? Product of the roots for this equation. Okay, so alpha beta will be equal to C divided by A. What is C value? 3 divided by A value is 1. So now this implies alpha beta is equal to 3. Alpha beta is equal to 3. Now with the help of these values, we are going to frame the new equation with the roots 1 by alpha comma 1 by beta. Students, so we came to the conclusion alpha plus beta equal to minus root 2 and alpha beta is equal to 3. Isn't it? Okay. Now we are going to form a new equation with the roots 1 by alpha comma 1 by beta. Yes or no? So first we are going to find the sum of the roots of 1 by alpha comma 1 by beta, product of the roots of 1 by alpha comma 1 by beta. After that we are going to form the quadratic equation. Okay. Now let's find the sum of the roots. Okay. So sum of roots of 1 by alpha comma 1 by beta will be equal to 1 by alpha plus 1 by beta. Since it is a fraction, what we will do, we will take LCM, isn't it? So alpha beta, now this becomes beta plus alpha. It is same as alpha plus beta or beta plus alpha because addition is always commutative. Okay, now we don't know the value of this one, 1 by alpha plus 1 by beta, isn't it? Okay, but we know the value of alpha plus beta and alpha beta. So we are going to reuse this value in this expression. So what will be the value? Alpha plus beta divided by alpha beta will be equal to minus root 2 divided by 3. Yes or no? Yes? Okay. So now we got the value of this which is equal to sum of roots. This will be the sum of roots. Okay. Now we are going to find the product of roots. Product of roots. That is product of roots. What are the roots? 1 by alpha comma 1 by beta. So now what will be the product of the root? 1 by alpha into 1 by beta. Yes or no? Shall we write it as 1 divided by alpha into beta? Okay. Now again here we are going to reuse the value of alpha beta what we got here. So it is 1 by 3. Yes. So now this is the value of the what? Product of roots. Yes or no? Yes? Okay. Now the values are ready now. We can frame the polynomial equation, quadratic equation. Okay. Now, okay, into this we know that what is the format of quadratic equation? That is nothing but x squared minus sum of roots into x plus product of roots is equal to 0. Yes or no? Okay. Now we found the values of the sum and the products, isn't it? Minus 2 root 2 divided by 3 and 1 by 3. Now substitute here x squared minus root 2 divided by 3 into x plus 1 by 3 equal to 0. Okay. Now we can leave the answer as it is, or again we can simplify the answer and give it in terms of a simplified form. What you will get? 3 when we take LCM. So this becomes 3x squared minus root 2x plus 1 is equal to 0. Again if this is multiplied, I'll get 3 into 0 will be equal to what? 0, isn't it? So I'll get 3x squared minus root 2x plus 1 is equal to 0. Either this answer or this answer, both are same. Okay. Did you understand this simple sum? Yes? Okay students, now look into this fourth sum, very simple sum too. If 1 root of k into x minus 1 the whole squared equal to 5x minus 7 is double the other root, show that k is equal to 2 or minus 25. So this is the thing we have to prove, that we have to show that k, the value of k is 2 or minus 25. This is the final answer. We have to prove it. In order to prove this, what are the clues given here? That is, the equation is given and also 1 root of this equation is double the other root. If 1 root is alpha, the other root will be double the alpha. So it is 2 alpha. Okay. Now shall we discuss and solve the value of k is equal to 2 now? Okay. Now look into this. First let us bring this equation into the quadratic equation. Of course it is in quadratic equation, but it is not a straight away form of ax squared plus bx plus c is equal to 0. So we are going to simplify this. As I told you already, whatever the term given in this term a minus b the whole square, we have to expand it. Okay. Now given k into x minus 1 the whole squared equal to 5x minus 7. Yes or no? Now you expand this. So k into a minus b the whole squared. A squared is x squared plus 1 minus 2ab. So this becomes minus 2x equal to 5x minus 7. Now we are going to make some simplifications over here. I am going to multiply k by this term. So kx squared plus k minus 2kx is equal to 5x minus 7. Yes or no? Okay. Now we are going to bring all the terms to this side. So we are going to make simple modifications in order to bring this equation into the format just ax squared plus bx plus c term alone. So kx squared now plus k minus 2kx minus, bring this term here, minus 5x plus 7 equal to 0. Now x squared is here. Now I am going to segregate the x term. See, here also I have x term and here also I have x term. So I am going to put together these two x terms and the constant terms separately. Now look into this. So I am going to bring it kx squared now minus 2kx minus 5x now plus k plus 7 equal to 0. Okay. Now look into this. Kx squared now minus, shall we take x common? Of course, minus x. Now this becomes 2k plus 5 plus k plus 7 equal to 0. Yes or no? Now look into this. X squared term, x term and the constant term. Now this is of the format a x squared plus bx plus c is equal to 0. Now the values are ready. Now take and write. What is a? It is k. Is that no? What is b now? Minus 2k plus 5. Yes. What is c? K plus 7. Is that no? Okay. Now after segregating the value of a, b and c, now we are going to move with the roots discussion and we are going to find the unknown values of k now. Shall we? Okay students, so we got the value of a, b and c. Okay, now we are going to discuss with the roots, isn't it? Now one root is alpha, the other root is twice the alpha, so it is 2 alpha. Now are the given roots. Are the given roots. Yes or no? Okay, now look into this. I am going to, as usual, I am going to find the sum of roots now. Sum of roots equal to alpha plus 2 alpha. Is that no? Okay. Now alpha plus 2 alpha is equal to what? Minus b by a. So now this becomes 3 alpha is equal to minus b by a. Already one minus is here. Minus into minus will become plus. So it is 2k plus 5 divided by k. Is that no? So look into this. We got the value of 3 alpha to be 2k plus 5 divided by k. Again from this I can simplify the result of alpha alone. So alpha will be equal to 2k plus 5 divided by 3k. Is that no? Okay. Now we can hold this value. Now let's move on to the product now. Product of roots. So what will be the product of roots? Alpha into 2 alpha, that is 2 alpha squared, which is equal to c divided by a. Is that no? Product of the roots. Okay. Now look into this. Now 2 alpha squared will be equal to c divided by a. What is c? K plus 7 divided by what is a? K. Okay. Now again here 2 is constant. We need not have the constant over there. So alpha squared will be equal to k plus 7 divided by 2k. Now look into this. We got this. Okay. Now what we are going to do? We are going to substitute the value of alpha into this expression in order to solve and find the value of k. Okay. Now shall we take this as first equation and the second equation? Now let's see how we are going to simplify it. Okay. Now look into this. We got the values of alpha and alpha squared, isn't it? So now what I am going to do, in order to solve the value of k, I am going to substitute the alpha value into this alpha squared expression. Shall we? Okay. Now look into this. Already we have noted this as first equation and this as second equation. So let me say it as substitute. What is that? Substitute first equation in second equation. Is that no? Okay. So what will I get? 2k plus 5 divided by 3k the whole square is equal to k plus 7 divided by 2k. Is that no? Okay. Now expand. See again a plus b the whole squared format. Now this square, you should be very careful. This square is common for both numerator and denominator. Okay. Now you have to expand the numerator separately and the denominator separately. Okay. Now numerator you have to expand it in the form a plus b the whole square. So this becomes a plus b the whole square, a squared plus b squared plus 2ab. So it is 4k square plus 25 plus, now 2 2s are 4, 4 5s are 20, isn't it? So 20k whole divided by 3k the whole squared is 9k squared equal to k plus 7 divided by 2k. Is that no? Now in order to make some simplifications over here, I am going to cross multiply. Since equal is in between, I am going to cross multiply this 2k this side and 9k square to this side. Before that, see here also I have 1k and I have 2k's here. So I am going to cancel out 1k. So now what will be the simplified form now? Look into this. Now I am going to take 2 to that side. 2 into 4k squared plus 25 plus 20k equal to 9k into k plus 7. Is that no? Okay. Now multiply 8k square plus 50 plus 40k. Is that no? Equal to 9k square plus 63k. Okay. Now since we have 9k squared on the right hand side, we'll bring all the terms to this side in order to avoid the subtraction symbol. Okay. Now bring it to this side. 9k squared plus 63k minus 8k squared minus 50 minus 40k is equal to 0. Now, okay. Now look into this. 9k squared minus 8k squared, we get k squared plus 63 minus 40k will give you plus 23k minus 50 is equal to 0. Okay. Now it has reduced into a simple quadratic equation and we are going to factorize this and find the value of k. Now we can factorize this using simple factorization which goes like this. So I have to split this into two numbers in such a way when I multiply those two numbers I should get minus 50. When I add those two numbers I should get plus 23. So it is plus 25 minus 2. Is that no? No, I can write it as k plus 25 into k minus 2 is equal to 0. So this becomes k is equal to minus 25 or k is equal to 2. Okay. Now look into this. We have proved the result. After all simple modifications, we have brought the value of k to be minus 25 and k is equal to 2. Hence, we have proved the result. Okay students, let's discuss this fifth sum. If the difference of the roots of this equation 2x squared minus a plus 1 into x plus a minus 1 equal to 0 is equal to their product, then prove that a is equal to 2. Now this is the final result we have to prove, that a is equal to 2. In order to prove this result, we have to use the clue that difference of the root is equal to their product. Okay. Now already we know that in this quadratic equation we can assume that alpha comma beta are the roots of this equation. Okay. Now let's see how we are going to proceed on. Now look into this. Alpha comma beta are the roots of this given equation. And we know that from the equation we have to take and write what is a value, what is b value and c value. Okay. Now we have segregated and written what are the values of a, b and c. From the given equation, what is given? The difference of the root. Now difference of the root is denoted as alpha minus beta. Now this is equal to alpha beta. It is the result what is given already. Okay, now let us take this as the first equation. Now from this equation, as usual, let us find what is alpha beta. Now alpha plus beta is equal to minus b by a. So what is minus b by a? Look into that. Minus, already one minus is here. B value holds one minus. So minus into minus will become plus. So it becomes a plus 1 divided by 2. Yes or no? So alpha plus beta value is equal to a plus 1 divided by 2. This is second equation. Yes or no? Okay. Now the other one, alpha beta. Some product of the roots, alpha beta is equal to c divided by a, which is equal to a minus 1 divided by a is 2. Is that no? Third one. Okay. Now look into this. We are going to make some modifications in order to prove the result a is equal to 2. Isn't it? Okay. Now look into this. What we are going to do, in this first equation, alpha minus beta is equal to alpha beta, I am going to substitute, replace the value of alpha beta. What is that? A minus 1 divided by 2. Why? In order to eliminate and bring into the form of the values alpha and beta. Okay. Now look into this. Substitute third equation in first equation. So now look into this. Alpha minus beta will be equal to a minus 1 divided by 2. Okay. Shall we have it as fourth equation now? Yes. Now what we are going to do? Look into this. I am going to add the second equation and the fourth equation. So these are two equations using elimination method. I am going to find the value of alpha first and then beta, and then we are going to substitute and find the value of prove the value of a is equal to 2. Shall we? Now look into this. We are going to add the second and the fourth equation using elimination method. So I am going to eliminate beta, plus beta and minus beta. So I will have 2 alpha here is equal to, now we are going to add this a plus 1 divided by 2 plus a minus 1 divided by 2. Since the denominators are same, okay, what happens? Plus 1 and minus 1 is getting cancelled. So 2 alpha is equal to a plus a is 2a divided by 2. Okay, now this 2 and this 2 is getting cancelled. So this implies alpha is equal to a divided by 2. Yes or no? Look into this. This 2 alpha is equal to a. So alpha is equal to a divided by 2. Now we are going to substitute alpha in any one of this equation in order to find the value of beta. Okay. Shall we substitute alpha value in the second equation? Substitute alpha is equal to a divided by 2 in the second equation. Okay. Now a divided by 2 plus beta equal to a plus 1 divided by 2. Now beta will be equal to a plus 1 divided by 2 minus a divided by 2. So now beta is equal to whole divided by 2. Now a plus 1 minus a. Plus a and minus a is getting cancelled. So beta takes the value, what is that? 1 divided by 2. Now for what purpose we are finding the alpha and beta value is in order to prove the result of the value of a is equal to 2. Now we know that, do you remember? Alpha minus beta is equal to alpha beta. Yes or no? Now I am going to substitute here. So now alpha minus beta is equal to alpha into beta. Now what is the value of alpha minus beta? Look into that. A minus 1 divided by 2. Yes or no? Is equal to alpha beta a divided by 2 into 1 divided by 2. Yes or no? So now this becomes a minus 1 divided by 2 equal to a divided by 4. Yes or no? Now 2 ones and 2 2s is getting cancelled. So this becomes a minus 1 is equal to a divided by 2. Now bring this 2 to that side. 2a minus 2 will be equal to what? A. Now bring this a to this side and minus 2 to that side in order to bring the value of what? A. So now this becomes a 2a minus a is equal to 2. Yes or no? 2a minus a is equal to a and a is equal to 2. Yes, so we have proved the result A is equal to 2 by finding out the values of alpha and beta using the clue that alpha minus beta is equal to alpha beta.